In this set of problems, we're looking to find the exact value, and we can do that by looking at it in terms of its exponential form. So if we take each of these and simply set it equal to y and rewrite it in its exponential form, we get 2 to the y is equal to 16, and then just rewrite your exponents in terms of the same base. So if we have 2 to the y is equal to 16, can be expressed as 2 to the 4th, therefore you see that y is equal to 4. And you can do that with each of these problems. Base 2 to the y is equal to 1 over 8. So 2 to the y is equal to, if we rewrite 1 over 8 using an exponent with a base 2, the 8 is 2 cubed, moving it to the denominator requires a negative sign, and so here we get y is equal to negative 3. In this problem we take our base 16 to the power of y is equal to 4. And so if we rewrite these using the same base, 16 is 4 squared. And so when you look at this, your power, unwritten power of 4 here is a 1, so 2y has to equal 1, which means y is going to equal 1 divided by 2. So that would be your solution. In problem 22, we take our base 27 to the power of y is equal to 9. Rewrite each of these using the same base. The common base, each of these can be rewritten in exponential form, would be a 3. 27 is 3 cubed to the y equals 9 is 3 squared. Therefore 3y has to equal 2, and when you solve for y, you get 2/3. Anytime you take a base or a log of 1, your value is always going to be the same, and we'll see why. If we take our base 7 to the power of y equals 1, in order to create a value of 0 using power, the power has to be 0. So y is going to equal, that power has to be a 0. So 7 to the 0 is equal to 1, so y in this case is 0. In problem 24, you have base 10 to the power of y is equal to 1,000. If you think of 1,000 as being exponent of the base 10 to the 3rd, you get y is equal to 3. Here you can rewrite it in exponential form. 10 to the power of y is equal to 0.01. 0.01 is like taking 10 to the power of 1, 2 to the left, or minus 2. Therefore, your y value is going to equal negative 2. Here we have a number, log base 10 of 10. Anytime you have the form where the base of your log and the value in the log are the same thing, you're always going to get the same expression 1. And we'll see why here. 10 to the power of y is equal to 10. The unwritten power here is a 1, so y is equal to 1. Problem 27, if we rewrite the form, we have 8 to the power of y is equal to 32. We need to express both these numbers in terms of an exponent with the same base. The base would be 2. 8 is 2 cubed to the y. 32 is 2 to the 5th. Therefore, we know that 3y has to equal 5. In other words, divide by 3, 5 is equal to, or y is equal to 5/3. In problem 28, we take our base 9 to the power of y is equal to 243. Rewrite these both using the same base. The common base between 9 and 243 in exponential form is 3. 9 is 3 squared. 243 is 3 to the 5th. Therefore, you can set their powers, equate their powers. 2y is equal to 5, which means y is going to be 5 over 2. For 29, it's your natural base, e. So here, if we think of our exponential form, we have base e to the power of y is equal to e cubed. Therefore, you see right away y is equal to 3. And finally, this last problem 30, base a to the power of y is equal to a squared. Therefore, you can see that y has to be a 2.